This lesson is about periodicity. All right, let's jump down to the interactive panel, head across here to periodicity and press play. Let's start by tracing another unit circle by dragging the log around. Okay, drag this around. Yep, come on little buddy, there you go, there you go. In the last lesson we saw how for a question like this, because theta equals negative root 3 on 2, if we're asked to find theta, we need to find any angles that give a side length of root 3 on 2. Alright. And because it's cos theta, root 3 on 2 is the length of which side? Well, cos is for the horizontal. Because it's negative, it's root 3 on 2 to the left or to the right. Negative means we go to the left, so left. Nice. Thank you. Then, because we're not told what sine theta is, the vertical side could go either up or down. Okay? And theta could equal either this angle, 150, or this angle, 210. Okay? So there's actually two answers for what theta equals. Although, we could also use negative angles to get to these points as well. Type in a negative angle to get to this point down here. Alright, that's like 180 and then come back a bit. So like 140 maybe? Oh, I used positive instead of negative, my bad. So negative 140. Okay, what about like negative 150? Oh, okay. Nice. Now use a negative angle again to get to this second point. Well, this one was 150 and this one was also 150. So what if it's 210? So what if we do negative 210? Ah. Interesting. Awesome. Okay, so there's 4 answers for theta then, right? 4 different angles that make cos theta equal negative root 3 on 2. Wow, it's like heaps. Well, it turns out there's even more than 4. There's actually an infinite number of angles that work. Okay, crazy. Let's play a game that will show how that's possible. Imagine Mr. Frog's child, Baby Frog, is over here, okay? And there's an insect nest over here, alright? In this game, first the frog needs to rotate around to get to the nest. Okay. So type in the angle that will rotate to the nest. Okay, so from here, rotating around, the nest is like there, so what would that be? Kind of looks like the 150 we had earlier. Maybe like 150? Okay. Nice. Now type in the angle to rotate to the baby frog. Type in the total angle, not just the angle from the nest to the baby frog. Okay. Also, if you notice, he's picked up an insect here and he's going to go feed it to baby frog. Alright, so we have to rotate like an extra bit to get to here, but it says to type in the total angle, meaning like from the start all the way around to the baby frog. So it's like a bit over 180, maybe like 200. Almost there, what about like 210? Okay. Nice, you fed baby frog. Oh no, an evil frog is coming to invade Mr. Frog's pond. Oh no. That guy looks really evil. Keep rotating around to 360 degrees so Mr. Frog can scare it off. Okay, so... Okay, we'll just type in 360. Wow. You really showed him, Mr. Frog. You scared him off. Nice job. Now, imagine the baby frog was hungry again. Oh, look at his little hungry little face. Mr. Frog would need to rotate around to the nest again to get baby frog another insect. Alright? So another 150 degrees. But he's already rotated a full 360 degrees from the start. So the second time he rotates to the nest, his total rotation would be 360 degrees plus 150 degrees, which equals, okay, well that'll be, it's like 36 plus 15, 41, 51, so 510. Okay, exactly. Interesting. Okay, And is the adjacent length still negative root 3 on 2? Yeah, we're in line with this thing here. So yes, it is. So we just found yet another value for theta that makes cos theta equal negative root 3 on 2. And you can check that on your calculator if you want. You type in cos 510 and you'll get the same as root 3 on 2. It'll be like negative 0.87, I think. Or to say it another way, we found another angle that makes an adjacent length of negative root 3 on 2. Now, type in the total rotation angle needed to get to the baby again. Remember, type in the total angle, not just the angle from the nest to the baby frog, so not just from here to here, and include the full 360-degree rotation we've already done. So from here around to here is what we want, but also we already did 360. So it's like here all the way around to 360, then an extra amount to get to here. Right, well last time we said that it was 210 to get to there, and then it was an extra, we need to do an extra 360 to count for the rotation we already did. So that would be 570. Nice, okay. So all the way around to 360, then an extra 210. So we just found two more angles that work by rotating around an extra 360 degrees. The evil frog is coming back. Oh no. This guy looks so evil. Keep rotating around so Mr. Frog can scare it off. Remember, we've already rotated 360 degrees, so count that into your answer. Okay, so 360, and an extra 360, that would be 720. Oh, you're in trouble now, evil frog. Mr. Frog looks very scary. Nice job. As you can see, this is why there's an infinite number of angles that will work. Because in each rotation, there's two angles that work. So there's one there and there's one there. Plus also, I guess, the negative ones, but if we're just talking about in one direction, if we're going this way, we'll hit once, we'll hit it twice, and then we'll go around. And each time we rotate around an extra time, we get two more angles that work. And there's no limit to how many times we can rotate around. Let's do one more rotation to prove that. Imagine baby frog is hungry again. Look how hungry that guy looks. So another 150 degrees again. But he's already rotated a full 360 degrees from the start, then another 360 degrees. So the third time he rotates the nest, his total rotation would be 360 plus 360 is 150. Oh, making me use my brain. It'd be like 360, 360 is 720. Extra 150 would be 870. Nice. You don't have to do that in your head, obviously. Feel free to write it down on paper or use your calculator if you want to. It's good practice to do it in your head though, or at least try it in your head. Is the adjacent length still negative root 3 on 2? Well, we're here, and yeah, still root 3 on 2 down there, negative root 3 on 2. It is, so we just found yet another value for theta that makes cos theta equal negative root 3 on 2. Wow. Now type in the total rotation angle needed to get to the baby again. Whoa, okay, it was 210 originally, right? So 210, and then we've done two full rotations, which is 720. So 930? Nice. Exactly, okay. 360, 720, and then 930. And then we're gonna feed the frog. So we just found two more angles that work by rotating around an extra 360 degrees. Oh my goodness. The evil frog is coming back. Oh no, this guy will mess you up. Keep rotating around so Mr. Frog can scare it off. Remember to count our previous rotations into your answer. Okay, so all the way around to here, which would be 360. We already had 720. So 720 plus 360 would be 1,080? Ugh. Come on brain. 720. 1,180? Oh no, this is embarrassing. Oh no. Wait, let me write this down. 720, 360. That should be 1,080. I swear I typed 1,080. I'm gonna check the recording later. I swear I typed, maybe I didn't press enter or something. Okay, anyways. Scared off that guy. Nice job. Another way to think about this is that if you add 360 degrees to an angle, that angle will also work. For example, find this angle. That looks like 60. Bang. Easy. Now use the exact value table to find the side length starting with the horizontal. Okay, so 60 degrees, 60 is here, and cos is the horizontal, so 1 over 2. Awesome. Here's a table again to find the vertical length. It's sine. Sine 60 is square root of 3 on 2. Nice. Now add 360 to the angle and type it in. So 60 plus 360 is 420. So we go all the way around. Okay. Yeah, so we're here and we just go around 360. We get straight back to there, but now we have a higher angle. And if we wanted even more angles that would work, we could just keep adding 360 on. So 420 plus 360, 780. All right, now my brain's properly awake. And 780 plus 360. Now I'm really working. 1,140. Nice. Awesome. And we could keep adding 360 on and keep getting more angles infinite times. Works in the negative direction too. If we have our 60 still, but this time we minus 360, it would be like rotating a full circle backwards. What's 60 minus 360? Negative 300. Okay, so this time we're going back this way, but we still end up at the same spot. Yeah. And then again, could keep subtracting 360 to get infinitely more angles. So negative 300 minus 360 is negative 660. Great job. Thank you. So let's put those skills all together now for these questions. I read that terribly. Anyways, if we get a question like this, sine theta equals negative 1 on 2. First, use the table to find the reference angle. So the angle that makes sine theta equal 1 over 2. Then use that to work out the first angle that would make sine theta equal negative 1 over 2 and type it in. Right. So, okay, so to get sine theta equal 1 over 2, sine 1 over 2, that needs to be 30, okay? Now, I think it doesn't actually want us to enter that as the answer, because now we just have to use the 30 to get the first angle that would make sine theta equal negative 1 over 2. Okay, sine's the vertical, and then negative would be down here, and then negative 1 over 2 would be like around here somewhere, right? So we're looking for something like this. And assuming that we're going positively, so around this way, we will probably want, we want to be down here first. And the second one would be once we get around to here. Okay, so this one here, using a 30, we'd go 180, then an extra 30 to get 210. Let's try that. Oops, I need to click back into the box. Okay, now type in the second one. So it'll be around to here, then keep going to here, because that would be in line with this. Okay, the ripples got a little crowded there, but anyways, I hope you get the idea. So maybe we go around to 360, then come back 330. Okay, so theta equals 210 degrees and theta equals 230 degrees, and that would get us both of these, which are in line with theta being negative 1 over 2, sine theta being negative 1 over 2. Okay. Now add 360 to get, now add 360 to each angle to get the next angles that will work, starting with the first one. Okay, so the first one was 210, add 360 to that. We get 570. Cool. And the second one will be 330 plus 360, which is 690. Great job. Thank you. All right. Awesome stuff. But if there can be infinite answers, how do we know how many angles to write down for our answer? Well, there's always a way to tell from the question. Either they will specify by wording the question like this, which basically means to find all the answers that work, but only where theta is between 0 and 720. So theta needs to be between 0 and 720. The actual meaning of this is literally theta is an element. It's kind of like E for element, of this set of numbers that goes between 0 and 720. And the square brackets here means that it can also include 0 and it also can include 720. And if it was round brackets, that means it can't include the 0 and 720, but it can include everything up to there. But yeah, once you get used to it, you'll just look at it and just go, okay, between 0 and 720, that's it. You don't have to worry too much about what that actually means. Or it might say it like this, which means the same thing. So technically, this means that 0 is less than or equal to theta, and theta is less than or equal to 720. So whatever theta is, it has to be, 0 has to be less than that, which means theta has to be greater than 0. So it can't be anything less than 0. I guess I just said that. But also, theta can't just keep going up to like 1,000,000. It has to also be less than or equal to 720. But as you can see, really it just means like this theta is between 0 and 720. That's all it means. And for negative angles, it looks like this, but it looks like this because we put the lowest number on the left. So 0 is a low number, right? But technically, negative 720 is less than 0 because 0 is here and then 720 is all the way over here. If you're putting on a number line, right? So yeah, but same thing. Theta is between negative 720 and 0. So, yep. And it doesn't always start with 0. Sometimes we might want to skip the first rotation, but have rotations 2 and 3. So maybe we don't just start at 0. We already think, okay, what if I've already rotated around 360? And then I keep going from there. And I go up until I get to 1080. I don't know why I said it like that. To 1080. Or maybe just skip the first half rotation. Okay, so we just go up to 180. So there, and then we look at what happens after that, but nothing before that. And sometimes we want negative and positive angles. For example, maybe we want the first negative rotation and the first positive rotation. So negative 360, meaning you can go all the way like there. Anything within there would work, but nothing like more negative than that. And 360 meaning like we can go the positive rotation, first positive rotation, but nothing after that. So there's lots of different variations. Or maybe a really strange one, like the first 1.5 negative rotations and the first 3 positive rotations. So negative 540 would be negative 360, and then an extra 180. So anything that's within that. And then 1080 would be 360 positively, another 360 positively, and then another 360 positively. So anything that's within those, but nothing outside of those. This is called the domain. So for this last set of practice questions, we're going to only give answers inside the domain that the question specifies. We'll mix up the domain notation so you can get used to each one. So sometimes we'll use this notation. So theta is an element of the set of numbers between 0 and 720, including them. Or just, again, literally just means theta is between 0 and 720. Sometimes we'll use this one. So theta is between those two things. But remember, they both pretty much say the same thing. We're only finding angles that are in between those two numbers. Let's put night mode back on too. I don't know why I said mode like that. Let's put night mode back on too. Try this first one. Using the exact value table to help, what's the first angle that would work? Whew, okay, so cos theta is going to give us root 3 on 2. For cos to be root 3 on 2, it has to involve 30 degrees, and it's positive. So we're just going to straight up just use 30. So, nice. So that's cos theta being root 3 on 2, and then 30 degrees is the angle that gives us that adjacent length there. All right. Awesome. Now, what's the next angle that would work? Remember, the main restriction is that the adjacent side needs to be positive root 3 on 2. Okay, so if I went around here, now our adjacent side would be negative because it goes this way. And then same for down here, that would also be negative. So I'd have to go, what about around here? Yeah, if I have an angle that goes down here, then the adjacent side would still be like that. Also, remember our cast thing? So we go C, A, S, T. And so because cos is positive root 3 on 2, we need to look for angles that are in the C quadrant, which is down here, and the A quadrant, which is up here. So A for all the things are positive. C for just cos is positive down here. So yeah, we want that and we want this. And then because it's root 3 on 2, we still need to involve 30-degree triangle. So down here, we'd have to put like we'd have to put a 30-degree triangle right here. So we could go around to 360 and then go back 30, so 330. I'm going to click on the box before I type it. There we go. Okay. Gotcha. Nice. Now, knowing that we can keep rotating past 360 degrees, what's the next angle that would work? Two things you can do here. You can visually just, okay, we keep going to 360, then we rotate a bit more to get to this angle here. And so, yeah, 390. Or you can just look at your answer. Okay, my answer here was 30. And I know that if I add on 360 degrees to that, I'll get another angle that would work. And then 30 plus 360 is 390. So both ways work. Great job. Now, if we kept going to get the next angle, would it fit inside the domain of 0 is less than or equal to theta, less than or equal to 540? So is it between those two numbers? Well, we can do it visually, or we can just look at the 330 and add 360 to it, which would give us 690, and that is not between 0 and 540. It's more than the 540, so no, it would not fit. That's right, the next angle that would work would be that. Yeah, I just said that. So we found all the answers for this question. Okay. Awesome, try this next one. What's the first angle that would work? All right, well, sine theta giving us root 2 on 2, sine root 2 on 2 is 45, and then it's positive, so yeah, just straight up 45 will work. Nice, thank you. Awesome. Now, what's the next angle that would work? Well, we still want a opposite side of root 2. Another typo. That's supposed to be root 2 on 2. My bad. Anyway, so we want a vertical length that's root 2 on 2 still. And so we could go there, or we could go across to here. Another way we could think about it is using CAST again. CAST. Sine is positive in the A quadrant and the S quadrant. And so we have to do something over here. Now we still need to involve 45 degrees, so we get a length of root 2 on 2. So if it was like 45 degrees in here, so 180 minus 45, 135. Nice. Now, if we keep rotating around, what's the next angle that would work? Right, well, if we keep going down here, there's no opposite lengths that are positive. They're all negative, so we're not going to get anything down here. We have to go all the way to 360, then add a bit, add on this 45. We can also just think about how 45 works, and then if we go 360 around, we'll get another angle that'll work just straight up. So 45 plus 360, 405? Nice. Great job. Now if we keep going around to get the next angle, would it fit inside the domain? Well, 135, we can add 360 onto that. And that would be 495, I think. Something like that. But that's definitely less than 540. So I think, yes, it does fit. Is it 495? Oh, it is. I'm just overthinking it, I guess. Nice. Great job. Okay, now if we kept going to get the next angle, would it fit inside the domain? A couple of ways to think about it. A really easy way is just get that angle again, so the 405, and add on another 360, which would be 765, I think. And that's definitely more than 540. You can also sort of do it visually, so we just went around 360, and an extra 180 would get you to the 540, which is here, and then you can't do anything else. And so we can visually see there's not going to be anything after that. Up to you. At a certain point, the number way of doing it kind of gets a bit easier, but it's good to have that visual understanding as well. So no, that will not fit. That's right. The next angle that would work would be 45 plus that. Yeah. So we found all of the answers to this question. Cool. Great job. Try this next one. Notice the negative domain this time. Make sure you consider that when finding your answers. Ooh. So now we have negative 900 and then 0. Alrighty. With that in mind, what's the first angle that would work? Because to give us a 1 on 2, we have to involve 60 degrees. Let's just jot that down real quick. Now, if it was 1 on 2, straight up 60 would just work, but it's negative 1 on 2, and also 60 is not going to be within our domain anyway, but we want negative 1 on 2. So cos is the adjacent, which is the horizontal, so left and right. So down here, negative 1 on 2, and then, it'll be like there or there. And we've got to use negative angles because none of the positive angles will fit between negative 900 and 0. So if we're going this way, the first one we'd hit would be here. Okay, and then involving a 60 means we go around to 180 and then back by 60. So I think 120, but we've got to put a negative there. Nice, thank you. Now it's kind of a lot to do in your head all at once. Feel free to kind of draw your own diagram in your book. That's what I do all the time. Awesome. Now, what's the next angle that would work? So we said the other one will be up here. And involving a 60, we go around to 180 and then an extra 60. So 240, but don't forget, we're going negatively. Nice. Great job. Now, if we kept going to get the next angle, would it fit inside the domain? Well, we can do it visually, or we can just grab the 120, add 360 to that, it'd be 480, and that's definitely below 900. So I think we're good for a little while. So yes. And then we just said 480. Don't forget to make it negative though. Nice. And then we could start thinking ahead for the next one as well. Will we get another one from the 240? So we add 360 to that, it'd be 600. Is that right? 600? More or less anyway. It's definitely below 900, so yeah, it definitely fits. Negative 600. Man, I'm second guessing myself so much after that that brain fart earlier. But the old brain is doing pretty good overall. Great job. If we kept going to get the next angle, would it still fit? So the 480, if we add 360 to that, 540, 840. Yeah, I think it still fits. That's right. So what's the next angle that would work? What did I just say? 940? No, 840. Don't forget to make it negative. Nice. Great job. Now, if we kept going to get the next angle, would it still fit inside the domain? I know it's a bit of a giveaway that this says like 5 out of 5. It kind of implies that it's finished, but let's think it through. The 600 plus a 360 would give us 960, and that's above 900, so we are finished. So we press no, it will not fit. Yep. So we found all the answers to this question. Cool. Awesome stuff. Next we'll do one with the domain that has positive and negative angles. Okay. Usually easiest to find the positive angles first, then find the negative angles. So what's the first positive angle that would work? Right. So negative root 2 on 2, but if we ignore the negative for a second, we just want root 2 on 2. Sine root 2 on 2 has to involve 45. And then let's visualize it. Negative root 2 on 2 is the vertical length would come down to like here or so. And then it goes, it's either here or there. So over here first, because we're using a positive angle, so around 280, then an extra 45, 225? Nice. Awesome. Now, what's the next positive angle that would work? All the way around to here and involves 45. So we can go around to 360 and then come back 45. 315? Nice. Okay, now it's probably going to ask us, will the next rotation work? So if we go 225, we add 360, is that 585? And that's less than 630, so I think yes, we can fit one more in. 585. Man, I'm smart. Okay, but will the next one fit? If we add 360 to that, that's 675. That's just more than that, so no, it won't fit. Yeah. So we found all the positive ones. Now, don't forget, we still have some negative domain here that we haven't considered yet. So let's check for any negative angles now. Reset log to 0. What would be the first negative angle that would work? Well, we're just trying to go down here. So negative 45. That's easy. Great job. Now, if we kept going to get the next negative angle, would it fit inside the domain? I think so. Go around to here, it's like 180 minus 45. Like we can already tell it's going to be less than 180, so yeah. And then it would be 135. Don't forget the negative. Perfect. Okay, but can we keep going from there? Well, we only allowed 180, so if we go past here, we're definitely past that. You can also add 360 to 45, 405, but and negative 405. But yeah, definitely more than 180. So no. Yep. That's what I just said. Found all the answers for the question. Cool. Very nice. Let's finish this lesson with one more like that, with the domain of positive and negative angles. All right. 810 and 450. All right. Usually easier to find the positive angles first, then find the negatives. So what's the first positive angle that would work? Sine theta to be a half, sine half would be 30, and it's just positive, and we're allowed positive angles, so that's just straight up 30. Nice, thank you. All right, the next one after that would be across here. So we could go around 180 and then minus 30, 150. Yeah, 150 is less than 450, so we should be good. Work it out, type it in. Nice. Great job. Now, if we kept going to get the next positive angle, would it fit inside the domain? Okay, so 30, we could add 360. Yeah, we get 390, so that fits. That's right, so what's the next positive angle that would work? 390. Great job. Now, if we keep going to get the next positive angle, would it still fit inside the domain? All right. 150 plus 360, 510? So that wouldn't fit. Okay, so no. So the next one was 510 was more than 450, so we found the positive angles. Okay, cool. And then visually you could think of the 450 as 360 to go all the way around, and then just an extra 90 would get you to 450. So anything past that won't work, which this one is past that. So, all right, let's check for negative angles now. Let's reset the log to 0. What would be the first negative angle that would work? We have to go all the way around to here and involve a 30, so 180, and then extra 30, 210, and negative 210. Okay, nice. Great job. Now, if we kept going to get the next negative angle, would it fit inside the domain? Well, we got 810, so I would say probably yes, but then we could work it out properly. So we go around to 360, then come back 30. That'll be negative 330. Nice. Great job. Now, if we kept going to get the next negative angle, would it fit inside the domain? So it was 210, and then an extra 360 would be 570, which is less than that, so we should be good. So negative 570. And then next one after that, I think it was the 330. So 360 on that would be 690. So negative 690, which is less than 810. So that's good. Yes, it'll still fit. Negative 690. Nice. Great job. And if we kept going to the next negative angle, would it still fit inside the domain? It'd be 570 was the last one that was over here. Extra 360 on that would be 630, 930. So I think, no, it won't fit. Okay, also, yeah, 7 over 7, that's a bit of a giveaway up there, but we won't have that in the test. So, yeah, we have to do it manually, and we can see that it won't fit. We found all the answers for this question. Great job. This also works the same for tan theta. Once you find some angles that work, you can just add 360 on and get more. That's enough for this lesson. Let's let Mr. Frog sleep. Good night. Right. Whoa. Whoa. Lots of stuff in this one. We unlocked level 9. So go ahead and try the practice questions here. Don't forget there's a video explanation that can show you how to approach the first few, or you can check your answers. You can see where you might have gone wrong. Then you can retry it yourself. And same for all those. Once you finish them, you can go ahead and tick off this lesson and move on to the next one.